Just a couple more examples of the fundamental counting principle. Here I have a pizza menu, and the options for purchasing a pizza include the different kinds of crust. You could get a thin crust, regular crust, or a deep dish. You have 5 toppings to choose from: pepperoni, ham, sausage, green pepper, and onion. And then 4 different sizes: a personal pizza, medium, a large, or a party pizza. Okay. And so with these options, the question is how many different pizzas could be ordered? And the answer to that is, well, how many one-topping pizzas could be ordered? We'll talk about other options there. So how many one-topping pizzas? Well, you could have a thin crust pepperoni personal, thin crust ham party, lots of combinations there, right? And so in the end, you take the 3 options from the crust, rather than sitting there and writing out all the different possibilities and branching them all off. You just take the number of options for the crust, the number of options for the toppings, and the number of options for the size, and multiply them together. 5 times 4 is 20, times 3 is 60. So this is 60 possible pizzas. Okay, so there are 60 possible pizzas that can be made off of just these options, which is quite a few, and this isn't even really that big of a list. A lot of places have quite a few more toppings than that. Now let's say for instance you wanted to have a 2-topping pizza, right? So this is for 1 topping. Let's say you wanted 2 toppings. Is topping spelled with 1 or 2 P's? 2 P's, oh my goodness, T-O-P-P. I thought that didn't look right. Okay, there we go. So for 2 toppings, you repeat the topping list twice. So you'd have 3 times 5 times 5 times 4, right? You'd be able to choose 2 of these options. Now I'm assuming you could actually have 2 orders of pepperoni. You could have 2 toppings, so 2 pepperoni pizza. Basically, it's double the pepperonis. If you were assuming you couldn't repeat, then you'd have to take, whatever you chose for the first topping, you'd have to take off and just use 1 less for the next option. But I'm going to assume you can double up on your toppings here. So 3 times 5 times 5 times 4, which is essentially 60 times another 5, which is 300 pizzas. Okay, so a lot more. Just by adding 1 extra topping, you go from 60 possibilities to 300 possibilities. And of course, if you couldn't repeat toppings, if you chose pepperoni as your first topping and you couldn't use that as your second, then you'd only have you'd have 3 times 5 times 4 times 4, which would be 240. So it would be quite a few less, but that would limit things. Anyway, let's look at another example here. Let's say you had a multiple choice test, which I never write. However, let's say you had one in another course, and there were only 10 questions, and each question had an A, B, C, or D option. Okay. The question then, or the problem then, is how many possible ways are there to fill that out? If you were to randomly fill in each of those answers, how many different ways are there to do that? And the answer is a lot, a whole lot. Basically, you have 4 options repeated 10 times. So that's 4 times 4 times 4 times 4, 10 of them, right? 4 options for each question. And so that's really 4 to the 10th power. Now, what on earth is 4 to the 10th power? Well, I have that here already. It happens to be 1,048,576 options. That's a lot, right? So the chances of getting a perfect score on a 10-question test with 4 answers each is 1 in 1,048,576. So that's very slim odds. You'd have to know what you're doing to get a perfect score. Now there are other combinations that may be more, that may show up more often, like, how 5 wrong or something. There's different ways to get 5 wrong, and so you have a larger chunk of these could get you a 50%, something like that. But at the end of the day, to get a perfect score, you only have one chance out of every 1,048,576 possible combinations. So, but on the same note, the chances of getting them all wrong are also 1 in 100 or 1,048,576. So, it's equal on either end. Anyway, no, that's not true. It's actually not true, because you can get them all wrong in many different ways. Oh, I said that wrong. Ooh. There are lots of different ways to get them all wrong. There's only one way to get them all right. So never mind what I just said. That's completely false. Can't believe I just said that. So there's only one way. So if question A, for instance, or if question number 1 had A as its answer, there's only one way to get it right, but there are 3 ways to get it wrong. So I don't know what I was thinking. And for every question, there's one way to get it right, 3 ways to get it wrong. So to get them all wrong, there's lots of possibilities. To get them all right, there's only one. So anyway, yes, good. Correction. Anyway, that summarizes a couple other options here. There's many things that you come across on a daily basis that have options to them, from buying furniture to, sitting down at a restaurant and ordering a meal. You're constantly making decisions throughout the day between different things, and those different combinations can really pile up. And so, this is just a way that we can count and figure out what the total number of options are, in an ideal situation.